Hey, what's up, Mr. Suda here. Today we're going to be talking about Newton's first law of motion. All right, just some real quick background. So this guy, Sir Isaac Newton, he was an English scientist and mathematician. He's famous for his discovery of the law of gravitation. He also discovered three laws of motion. He published this really important book, or I guess you could call it a thesis. The very important ideas that he published back in 1687. Today, these laws are known as Newton's laws of motion, and they describe the motion of all objects on the scale we experience them in our daily lives. All right, so here's a picture of Newton, or a painting, I should say, and a really good quote from him. If I have ever made any valuable discoveries, it has been owing more to patient attention than to any other talent. Right, really good quote, give you something to think about. All right, so Newton's first law. Let's start off with his first law. So Newton's first law says an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So what does this mean? So basically, an object is going to keep doing what it's doing unless it's acted upon by an unbalanced force. If the object was sitting still, it's going to remain stationary. It's going to continue to sit still. If the object was moving at a constant velocity, it's going to keep moving. It takes a force to change the motion of an object. Remember, how is force defined? Force is defined as a push or a pull on an object. What is it meant by unbalanced force? So if the forces on an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. If the forces are not equal and opposite, then the forces are unbalanced and the motion of the object changes. For example here, gravity pulls downwards on this book and exerts a gravitational force downwards. The table then pushes upward on the book with an equal and opposite force to that gravitational force. Because the force downward is equal to the force upward, the forces on the book are balanced and the book does not move. Let's look at some examples from real life. So a soccer ball is sitting at rest. It takes an unbalanced force of a kick to change the motion of the soccer ball. We have two teams playing tug of war. They're both exerting equal force on the rope in opposite directions. This balanced force results in no change of motion. Because they're balanced forces, there's no change of motion. Newton's first law is also called sometimes the law of inertia. Inertia is the tendency of an object to resist changes in its state of motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has, and the harder it is to change its motion. So who here has more inertia? The elephant, the person, or the ladybug? So let's look at the information given. The elephant weighs 1,000 kilograms, the person weighs 80 kilograms, and the ladybug looks like it weighs 10 to the negative fifth kilograms, really small. Right, so which one has the most inertia? Well, the elephant has the greatest inertia, the person has the next most inertia, and the ladybug has the least amount of inertia. The greater the mass of an animal or an object, the greater its inertia must be. The elephant has the most inertia because it has the greatest mass, and the ladybug has the least inertia because it has the smallest mass. Some more examples from real life. A powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia, and it takes a very large force to change their motion. Once they're moving, it takes a very large force to stop them because they have a lot of inertia. Another example here, on your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia. The bug has a very small mass. So because it has this very little inertia, it exerts a very small force on your car, so small that you do not even feel it. However, the bug, because the car is very large, the car has a lot of inertia, it hurts the bug very badly. All right, so why should you wear your seatbelt? We'll wait for this to start up again. So we have this car, and the car is driving, and it hits the wall, and this person, they go, and they fly out of the car. Why does this happen? Right, so your seatbelt supplies the unbalanced force to stop your forward inertia from launching you from the car. So while the car is moving forward with you in it, both you and the car have inertia. When the car hits the wall, the car stops and it loses its forward inertia. However, you, the person in the car, still have your inertia, So your forward inertia carries you up and out of the car. If you were wearing a seatbelt, it would have been able to supply an unbalanced force to stop that forward inertia, causing you to stay in the car and not lead you to fly out of the car and get badly injured. So if objects in motion tend to stay in motion, why don't objects keep moving forever? So things don't keep moving forever because there's almost always an unbalanced force acting upon it. For example, a book sliding across a table slows down and stops because of the force of friction. If you throw a ball upwards, it'll eventually slow down and fall because of the force of gravity acting upon it. Another example here, in outer space, away from gravity and any sources of friction, a rocket ship launched with a certain speed and direction would keep going in that same direction and at that same speed forever, right? Because there's no unbalanced forces in space, there's no gravity, there's no friction. So a spaceship could keep moving on forever and ever. You could say, well, if that spaceship will continue moving at that speed forever, why can't we reach distant planets? The reason is you would run out of food before you could get there, right? That's going to wrap it up for Newton's first law. Thanks for watching. I hope you learned something, and I hope to see you in the next video.